Tonight, we bring you a breaking geological emergency. Mount Etna, the fiery giant of Sicily, is behaving in a way that is terrifying scientists. This isn't just about glowing lava or ash clouds rising into the night sky. This is something far more serious, a slow, silent disaster that's happening deep beneath the surface. For the first time in recorded history, scientists have confirmed that Mount Etna's entire southeastern flank, a block of rock weighing billions of tons, is breaking apart and sliding toward the sea. The data is clear, the warnings are loud, and experts now fear that a catastrophic collapse could be imminent. This is the story of how one of the most active volcanoes on Earth may be on the brink of tearing itself apart. Mount Etna has always been known for its eruptions. For thousands of years, it has towered over the island of Sicily, shaping its landscape and the lives of everyone who lives near it. But while people have learned to live with the eruptions, they've never faced anything like what's happening now. Satellite data, GPS readings, and seismic instruments all point to one conclusion: the volcano is becoming unstable. The southeastern side of Etna is moving not just by a few millimeters a year, but now by several centimeters a month. It's a movement that scientists describe as a slow-motion collapse, a geological process that could, at any moment, turn into one of the most devastating natural events in modern history. What's happening beneath Etna is both fascinating and terrifying. Magma rising from deep inside the Earth is pushing its way through cracks and fractures within the volcano, forcing the mountain apart from the inside. As the magma moves upward, it heats and melts the surrounding rock, increasing pressure within the structure. That pressure forces the southeastern flank, the side facing the Ionian Sea, to slowly slide downward. And as it slides, it creates more space for magma to intrude, weakening the volcano even further. It's what scientists now call a volcanic feedback loop, a cycle where each movement accelerates the next. The more the flank moves, the more magma seeps in, and the more unstable the entire volcano becomes. But this isn't just about magma or pressure. Gravity itself is now taking over. The southeastern flank is enormous, billions of tons of rock resting on steep slopes above the sea. Once that slope begins to shift, gravity pulls relentlessly downward. The German research team at the Geomar-Helmholtz Center found that the entire lower base of the volcano, including parts beneath the sea, is sliding along a weak layer of sediment and ancient lava. Their sensors recorded steady movement along that boundary, proving that Etna's instability is no longer confined to the summit or surface. The entire structure is shifting from the inside out, and history shows just how dangerous that can be. In 1669, Mount Etna unleashed one of its most destructive eruptions ever recorded. The ground on its southern flank cracked open without warning, miles below the summit. From those fissures, a river of molten rock poured out and devoured everything in its path. It destroyed 14 villages, buried parts of the city of Catania, and even extended the coastline by more than a kilometer. The pattern of ground deformation seen before that eruption matches the same pattern satellites are detecting today. The difference is that the forces at play now are larger, deeper, and far more extensive than what was recorded in the 17th century. That is why scientists fear history may not just repeat itself, it may do so on a catastrophic scale. If the southeastern flank of Etna collapses suddenly, the results would be devastating. Imagine billions of tons of rock crashing into the Ionian Sea within minutes. The displacement of water would create a tsunami capable of racing across the Mediterranean at hundreds of kilometers per hour. Waves up to 50 meters high could strike the Sicilian coast within minutes. Within an hour, those same waves could reach Malta, Greece, and the North African shorelines. Major cities and tourist centers across the Mediterranean could find themselves hit with little to no warning. The tsunami simulations are not speculative. They're based on real data from the structure of Etna's slopes and the geometry of the seafloor. Scientists warn that such a collapse could rewrite the geography of the Mediterranean basin itself. But what makes this scenario even more alarming is that there may be no clear signal before it happens. Unlike explosive eruptions, a flank collapse doesn't necessarily come with roaring explosions or clouds of ash. It begins silently, deep underground. Sensors detect subtle changes, tiny earthquakes, slight accelerations of movement, shifts in the tilt of the ground. Then, once a certain threshold is reached, the entire structure can fail in minutes. The cracks that have been creeping outward for years suddenly tear open, and the mountain gives way. Right now, those warning signs are multiplying. Clusters of small earthquakes are appearing exactly along the lines of the sliding flank. Ground sensors have recorded periods of acceleration, short bursts when the movement of the slope increases before slowing again. These are like the mountain's pulse, the rhythm of a system under stress. Scientists from Italy's National Institute of Geophysics and Volcanology have been watching the data closely. Dr. Alessandra Moretti, one of the lead researchers, recently said Etna's southeastern flank is in continuous motion. It's not a matter of if it will collapse, but when. The only question is how much warning we'll get before it happens. This process, according to the latest studies, is being driven more by gravity than by magma pressure. That means it won't stop even if the volcano remains quiet on the surface. The mountain's own weight is pulling it apart, like a glacier that begins to slide down a valley. The movement may start slow, but it can accelerate rapidly once friction is overcome. And when billions of tons of volcanic rock begin to move, there is no human force capable of stopping it. Authorities in Sicily are aware of the danger, but managing such a threat is incredibly difficult. The volcano is vast, the population around it dense, and the timeline uncertain. How do you evacuate thousands of people when you don't know if the collapse will happen next year or in a decade? For now, emergency protocols are being reviewed, particularly in the towns on the lower slopes and along the eastern coast. But outside of scientific circles, few residents fully understand what's happening beneath their feet. Daily life continues, even as the ground beneath them creeps toward the sea inch by inch. This is why scientists are urgently calling for enhanced monitoring, not just on land, but underwater. The movement of the submerged base is critical, yet few sensors currently exist on the seafloor near Etna. That's where the earliest warning could come from, because a sudden acceleration underwater would mean the slope is about to fail. The challenge, however, is that installing such instruments is technically complex and expensive. Researchers argue that given the stakes, the investment is worth it. A single collapse could affect millions across several countries. Meanwhile, Etna itself continues to erupt intermittently, as it has for centuries. But these eruptions may no longer be harmless releases of pressure. Each time magma rises, it forces the mountain's internal fractures wider, loosening the already unstable flank. It's as if every eruption adds one more crack to a breaking dam. The recent eruptions of 2021 and 2023 produced spectacular lava fountains, but they also coincided with measurable increases in flank movement. This connection between eruption and structural sliding suggests the feedback loop is not theoretical. It's happening right now. To understand the scale of what could happen, scientists point to other volcanoes that have suffered major collapses. In Hawaii, ancient flank failures produced debris avalanches that stretched hundreds of kilometers across the ocean floor. In the Canary Islands, the collapse of a volcanic flank is believed to have generated tsunamis thousands of meters high in prehistoric times. These examples are reminders that volcanic collapses are among the most violent geological events possible, capable of reshaping continents and oceans in a single day. Etna, sitting on a densely populated island surrounded by coastal nations, represents perhaps the most dangerous scenario imaginable in modern Europe. For now, the mountain's movement continues slowly but consistently. Each year brings new measurements showing slight acceleration. The cracks widen, the earthquakes cluster, and though most people see Etna as a symbol of beauty and resilience, the truth is that it is disintegrating. The volcano is tearing itself apart from within. What began as a geological curiosity has become a potential continental threat. Experts warn that even minor triggers could set off a collapse. A moderate earthquake, a sudden injection of magma, or even extreme rainfall saturating the fractured rocks could destabilize the flank enough to make it fail. The challenge is that nobody can predict which of these will be the final push. When it happens, it will likely happen fast, too fast for any large-scale evacuation. This is why people across the Mediterranean should pay attention to updates from Italy's National Institute of Geophysics and Volcanology and local emergency agencies. The threat is not confined to Sicily alone. A collapse would generate seismic waves and tsunamis that could reach multiple nations. For coastal residents of Malta, southern Italy, Greece, Tunisia, and even parts of Libya, the first warning might be a sudden drop in sea level, followed by a wall of water racing toward shore. Scientists emphasize that early detection and coordinated international alert systems will be crucial in saving lives if the worst happens. As of now, Mount Etna continues to tremble. Instruments record its heartbeat every second. It exhales gas, releases lava, and shifts ever so slightly toward the sea. To the untrained eye, it looks peaceful, even majestic, but beneath that calm surface lies a system stretched to its limits. The forces inside are growing, the slopes are weakening, and the countdown, though invisible, has already begun. This is not fear-mongering. This is data. The evidence from satellites, GPS stations, and underwater sensors all tell the same story. Etna's southeastern flank is moving. The mountain's internal structure is cracking apart. The pressure and gravity are working together, driving the volcano toward a point of no return. Scientists are not saying if it will happen, they are saying when. And when it does, the consequences could echo across the entire Mediterranean. So as you watch Etna glowing on the horizon, remember that the true danger is not the lava that lights up the night sky. It's the slow, silent shifting of stone beneath the surface, the kind of movement that reshapes coastlines and rewrites maps. This is a race against time, against nature, and against our own ability to prepare for what's coming. This has been your news alert. Mount Etna is cracking apart. Scientists say collapse is imminent. Stay alert, stay informed, and keep your eyes on the Earth, because it's alive, it's restless, and right now, it's trying to tell us something.